Hi everyone, just a quick little video here to remind you that we have a quiz tomorrow, and also wanted to remind you on what sorts of things to expect. So like I had mentioned, part of the short quiz, and this should take between 10 and 15 minutes, definitely by 15 minutes we should be done. And part of it will be on a change of state question. And this will be change of state, and it will definitely be on a perfect gas, so we don't have to concern ourselves with the van der Waals gas or the van der Waals equation this time around for this quiz. And so therefore the PV equals nRT equation will serve us very well. And by change of state, what I'm getting at is that a gas is in an initial equilibrium state, which we've been calling state 1, and it undergoes some sort of change that involves a path, whether that's isothermal or isobaric or isochoric, that sort of thing. And then it equilibrates in state 2, and we can characterize each state by the values of its physical properties. So we have N, and temperature and volume and pressure for our gas. We've also talked about internal energy, but that's not included on this quiz question. And we have the same thing defining the state 2 over here. Now, our perfect gas is also going to be part of a closed system, so I don't have gases coming and going. I'm not adding number of moles or losing any number of moles. And so N1 is equal to N2, and I've just kept it as N. But T1, V1, and P1 may change their values depending on what sort of change this is, and so we'll just write in T2, V2, and P2. Okay, so since the perfect gas law applies, I know that P1, V1 is equal to nRT1. And therefore, P1 V1 over NT1 is equal to R. Oh, sorry, I was out of view on that. Let's just fix it. Okay, and the same thing can be said over here. P2 V2 over NT2. So this is what I'm looking for, this sort of logic. Okay, after you write out all of your given. And then we go back and consider what sort of change it is. And say, for example, this one was an isothermal change on a closed system. Well, since it's closed, the number of moles are the same. So what I'm doing here is really pointing out that since both of these are equal to R, they are therefore equal to each other. And so now I can cancel what's the same on both sides. And if it's isothermal, T1 and T2 are the same, so that cancels. And so my equation becomes very simple. P1 V1 equals P2 V2. Of course, I could have started with this, but I'm looking for this sort of logic. And so the starting point is always the same. And again, for example, if we were asked to find what is the final volume, so as an example, P2 equals what? P2 isolated, of course, is P1 V1 over V2. And the other thing that I tried to point out to you guys is to put these similar properties on top of each other here so that you recognize that you may not know exactly what V1 and V2 are. You don't know their individual values. All we need to know is their ratio to answer this question. So you may just be told that the volume increases or decreases by a certain amount, pardon me, not by an amount, by a certain factor, by a certain percentage. Okay, so that's what I'm getting at there for the change of state question. Okay, let's stop it there, and we'll do the virial type equation on another mini video.